Again, these lectures cover the big data in manufacturing using analytics in production. Our main objective is to describe how big data is used in manufacturing. So in manufacturing, big data is a term used for massive volumes of data generated in production environments, including data produced by machine sensors, production process, and other systems. Big data can be highly complex and variable, and is often generated and delivered at high speed. So companies can harness this data for application such as production process optimization, operational efficiency improvement, quality control, predictive maintenance, and supply chain management. So again, big data is transforming the manufacturing industry by enable smarter decision making, increase efficiency, and predictive capability. So here we're going to go through the clear breakdown of how big data is used in manufacturing. So first, what is a big data in manufacturing? So we know big data refers to extremely large and also complex data sets that traditionally data processing software cannot handle. So it's not just about the size of the data, but also different types of data, the variety, and also the velocity, which is the speed at which it's generated, and often the volume, the sheer amount. So again, the value of a big data lies in its analysis, which can uncover trends, patterns, and insights that help organizations make better decisions, also improve processes, and create new opportunities. So we can say the characteristics often used to describe big data are known as the V's. And here we have the three V's. For example, volume. Volume will be the massive amount of data or the sheer amount of data. Velocity will be the speed, data generated at high speed. So the speed at which the data is generated and also processed. Now, variety will be the data are different types. So different types of data, they can be structured, semi-structured, or unstructured also. We also have two more V's, the veracity and also the value. So the veracity is the accuracy and also the reliability of the data. Value will be the usefulness and insight that can be derived from the data. So most textbooks give us five V's. Again, the volume, the velocity, the variety, uh, veracity. Veracity again is based on the accuracy and reliability of the data, and also the value, that's the usefulness. So in summary, big data is about dealing with large data, fast and also diverse data set to extract valuable information for decision making and also problem solving. So why big data analytics in manufacturing? So here we have some few lists: unlock the insights, improve efficiency, enhance quality, better decision, and also drive innovation. So big data analysis is very crucial, it's a very vital in manufacturing for several compelling reasons. One of the reasons, also, as we said, improve efficiency and productivity. So here by analyzing data from machines, sensors, production lines, manufacturers can identify the bottlenecks, also optimize processes, and improve overall equipment effectiveness. So this leads to, again, increase throughput and also reduce waste. Predictive maintenance also can be one of the and also enhance quality control. As we said, this will be proactively identify and prevent defects. To optimize supply chain management also is possible. So, for example, analyzing data related to suppliers, logistics, and demand patterns will help optimize the supply chain line. Also, this can lead to better inventory management, reduce lead times, and also improve responsiveness to market changes. Better demand forecasting also is possible. Here, by analyzing historical sales data, market trends, and other relevant factors, manufacturers can improve the accuracy of demand forecasts, so a prediction. So this helps in planning production schedules, managing inventory effectively, and also reducing the risk of stock outs or even overstocks also. Cost reduction is possible, as we said, through the previous point. We can also improve efficiency, predictive maintenance, better quality control, optimize supply chain, as we said, and this can lead to, again, cost reduction. So big data analytics always contributes significantly to cost reduction in manufacturing operation. Also analyzing the customer feedback, market trends, product usage data can provide valuable insight for designing new products or even improving an existing ones to better meet customer needs. So we have the predictive maintenance. So predictive maintenance normally uses data analysis and also techniques to detect anomalies in equipment and also predict when maintenance might be needed. So this allows maintenance tasks to be scheduled only when necessary. Now, preventing unexpected failures and also minimizing the downtime. So analyzing historical and also a real-time data from equipment allows for the prediction of potential failures. Also, this enables, I would say, proactive maintenance, minimize downtime, reducing repair costs, and also extending the lifespan of machinery. Next is the quality control and defect detection. So big data analytics enable the real-time monitoring of product quality at various stages of production. So by identifying patterns and also anomalies, manufacturers can detect defects earlier, also reduce scrap, and ensure consistent product quality. So analysis of large volumes of production data is also that can lead to quality control also. For example, manufacturing processes always generate vast amount of data from various sources. As we mentioned earlier, sensor data, process parameters, even quality checks. This can be a manual inspection result or automated measurements. Also the environmental data, maybe humidity, the temperature in the facility. So big data analytics can process and analyze this massive data set to identify patterns and also possible correlations that might be invisible to traditional methods. So again, you can get data from sensors data, process parameters, as we mentioned, also the quality checks and also the environment data. So production optimization will also be one of the main concerns here. So with big data, manufacturers can optimize their production process. So process parameter optimization by analyzing historical and also the real-time data on machine settings. Example can be temperature, speed, and so pressure. Material inputs and environmental conditions. Big data analytics can identify the optimal parameters that can lead to, again, highest quality output, lowest waste, and also most efficient resource utilization. Also possible optimization process, also we need to identify the bottlenecks or bottleneck identification. Here, analyzing data on a cycle times, machine utilization, and material flow can pinpoint bottlenecks in the production line. Now, once identified, these bottlenecks again can be addressed through process redesign or resources reallocation or technology upgrade that lead to a smoother and a more faster overall production. So resources allocation and schedule vary also. These two things can lead to optimization of production. So big data can optimize the allocation of resources. Example of resources in this case can be labor resources or material or energy, based on a predicted demand. Also machine availability and a process requirement. So this can include optimizing the product schedules to minimize idle time, reduce work in progress inventory, and also meet the delivery deadlines more effectively. So again, insights help reduce waste, as we mentioned earlier, speed up production, and improve resource allocation also. So next is the supply chain analytics. Here we say big data integrate information across suppliers, inventory, logistics, and demand. So we may have the demand forecasting, that's predicting future demand to optimize inventory levels. Also, supply management. So this enable, again, real-time inventory tracking, demand forecasting, as we said, supplier performance analysis also. Next is, again, the product design and innovation. So customers' feedback are very important. User data or usage data, social media insight are analyzed to understand product performance. Also, manufacturers use this data to refine product designs and also develop a new offering that meet customers' need. Now, next we're going to discuss about the risk management aspect. One of the main goals of risk management is to identify potential disruptions, and also developing mitigation strategies to avoid. So risk management is very important. Big data tools monitor and also log operational data for regulatory compromise. So a real-time risk monitoring, this can be due to the velocity of big data. This allows for continuous monitoring of risk factors in real time. So this enables organizations to detect and also respond to emerging threats much faster than with periodically assessment. So for instance, in cybersecurity, let's say a real-time analysis of a network traffic can identify and also flag suspicious activities immediately. We also have operational risk management. In areas like manufacturing or logistics, big data from sensors or IoT devices and also operational system can be analyzed to identify, again, potential operational risks, such as equipment failure and supply chain disruption, as we said earlier also. So we can say in summary, big data analytics empowers organization to move from reactive to proactive risk management by providing, again, deeper insights, possible more accurate prediction, and also real-time monitoring capabilities. So next section is some few examples we have. So this is example technology use. We know Apache Spark, Hadoop for large-scale data processing. Another is IoT sensors and also edge computing for real-time data collection. Also, we have AI and machine learning for predictive analytics and cloud platforms such as Amazon, AWS, and also Azure for scalable data storage and computing. One of the main goals also in this big data in manufacturing, also identify, let's say, hidden coalitions. As we mentioned, traditional risk management often focus on the known risk factors, but big data analytics can uncover unexpected correlation between seemingly unrelated variables that may or might indicate emerging risk. For example, analyzing a social media sentiment alongside economic indicators may provide an earlier warning of potential market instability, not stable instability. So now we'll go through some of the key applications. We start with the predictive maintenance. Here, as we mentioned earlier, analyzing the sensor data, for example, vibration, temperature, etc., to predict equipment failures, predictive maintenance. So the benefit, of course, will be the reducing downtime, also lower costs in maintenance. And this will increase the lifespan of the assets. So example, giving a predicting with a machine bearing is likely to fail and schedule maintenance proactively. So predictive maintenance evolution has been, let's say AI and machine learning will further refine the predictive maintenance capabilities, also enable more accurate forecasting of equipment failures, again, based on the real-time sensor data, potentially with equipment manufacturers proactively reaching out for service. And the next will be the quality control. So big data analytics, for example, help GE company to monitor quality parameters in real time. We see the example, for example, identify deviations and also predict potential product defects. This allows for earlier detection of issues and also implementation of corrective action to maintain consistent product quality. So identify faulty component on an assembly line using image analysis. Will be it. Then next is the key application of supply chain optimization. And here we mention analyzing data across supply chains, such as suppliers, logistics, inventory. So these are the benefits to optimize inventory levels, reduce lead times, improve supplier performance, and also enhance resilience. So example here, predicting potential disruption in supply chain and finding the alternative solution. So next will be production optimization, which we mentioned earlier also. So the benefits here mostly will be increased production output, lower the per unit cost, and improve, again, resource utilization. So analyzing a warehouse layout, the storage strategy, and picking process to improve efficiency and reduce operational costs. This can be a warehouse, again, optimization. example. So that's the example we're trying to explain. So the General Electric, again, uses the big data and analytics in its factories to reduce unplanned downtime, also by predicting machine failures, saving millions in maintenance costs annually. And we have the reference on this article on GE uses of big data in their manufacturing production line. So what are the challenges? As we mentioned earlier, challenges is about, again here, data analytics. So data analytics, always we talk about data. So we will say the number one will be the data quality issues. This is also pertaining to machine learning, tax, etc., or supervised like model building, etc. Data quality, because as we know in computer science, the saying is that garbage in, garbage out. If you have a bad data, you end up having a bad decision. A good data may give us a good model or a good decision system. So data quality and integration is one of the challenges. Here, the manufacturer's data often comes from diverse sources. For example, we mentioned sensors, machines, enterprise system with varied formats, different types of format of data, structured, unstructured, semi-structures, and the quality also different. So ensuring data accuracy and also consistency and completeness and integrating these disparate sources can be very complex and time-consuming process or task. So example will be sensor readings might have noise, or different machine might log data in different units. Another challenge will be integration of disparate system, also lack of skilled personnel, infrastructure and the cost, and also data security, and also privacy. Now here we are discussing about big data analytics. So the volume of the data, actually both volume, velocity, and variety of the data can be also a challenge. So the sheer volume of data generated, the speed at which it's generated, and the different types of data, unstructured, like image from quality, can overwhelm the traditional data processing system. Also, infrastructure and technology investment can be another challenge. As we mentioned earlier, the lack of skilled personnel also is a challenge. So analyzing a big data effectively requires a skilled data scientist or data engineers, data miners, etc., or even domain experts who understand both the manufacturer process and also the data analytics techniques. So finding and retaining such talent can be a challenging. And as we mentioned, also data security and privacy. So manufacturer data can include sensitive information. So ensuring the security and privacy of this data, especially when dealing with interconnected systems and cloud platforms, is crucial and also require robust cybersecurity measures. Also, we can say the legacy. A legacy system and also interoperability can also be an issue, challenge, because many manufacturer plants still rely on old system, legacy system that are not designed to easily integrate with the modern big data analytic platform. So this can be a challenge also. So making the system work together can be a significant challenge. So let's see, what is the future of big data in manufacturers? So here we say, in essence, I would say the future of big data analytics in manufacturers is about creating smarter, more efficient, resilient, and also sustainable production process through the powerful combination of big data analytics techniques, also including AI connectivity, etc. So the future of a big data analytics in manufacturing is poised for a significant advancement, driven by the increasing adoption of IoT, AI, also machine learning concepts, etc., also data science techniques. So a smarter and autonomous system will be one of our main glimpsing into what the future hold. Let's say, hyper personalization system. Like data analytics will enable manufacturers to cater to a growing demand for customized products by analyzing customer data and adapting design and production level accordingly. So this will be high personalization. And also we mentioned digital twins for simulation and optimization. So the use of digital twins, which is again, virtual representation of physical assets, will become more widespread. So again, this will be powered by real-time data, and it will allow for, again, scenario testing, performance optimization, we mentioned about predictive maintenance, etc. Yeah. And also AI-driven quality control will be, again, so AI-powered machine vision, advanced analytics will enable more sophisticated real-time quality monitoring, capable of, again, sophisticated real-time quality monitoring, capable of, again, detecting even minute defects and ensuring high product standard. So in summary here, we say big data in manufacturing enable a shift from reactive to, again, proactive, as we mentioned, by the risk management, predictive maintenance, etc. Also improve efficiency, quality, and also innovation. So we are going to end the lectures here. Again, if you have any question about the assignment for this week, again, you can send an email. Thank you.